This is the video lesson for examples using the equation for work. The learning target for this lesson is, I am learning to use the work equation to solve real-world problems. The success criteria for this lesson are, I can recognize the necessary conditions for work to be applied to an object, and I can use the equation for work to solve real-world problems. So here we have the equation for work. W for work equals F for force times D for displacement. So we have W for work, F for force, and D for displacement. And then here we have them rearranged, the equation rearranged so that we have solving for force. So force is equal to work divided by displacement. And then here we have the equation solved for displacement. So we have D for displacement is equal for W work divided by force. So displacement is equal to work divided by force. All right, let's look at a few examples of using the work equation to solve problems involving work. All right, so you are driving down the road in your truck and you run out of gas. You and your friends apply 1,100 newtons of force to your truck to push it the 215 meters to the nearest filling station. How much work did you and your friends do on your truck? Okay, so we have work equation is force times displacement. So our force here is 1,100 newtons times 215 meters, which gives us a total of work of 236,500 joules of work. So if we look at our units here real quick, we have newtons times meters. And newton is a kilogram times meters per second squared. So we multiply that by meters, and we end up with kilograms times meters squared per second squared, which is equal to joules. All right, example number 2. Tyrone does 15 joules of work to push a pencil over 1 meter. How much force did he use? All right, so our equation here is force is equal to work divided by displacement. So he did 15 joules of work. So we have 15 joules of work divided by 1 meter. So that means that Tyrone did 15 newtons worth of work. All right, and again, joules is equal to kilograms times meters squared per second squared, and we divide that by meters, and we end up with, we cancel one of the meters there on the top, and we end up with kilograms times meters per second squared, which is equal to newtons. All right, example number 3. Angela uses a force of 25 newtons to lift her grocery bag while doing 50 joules of work. We want to know how far did she lift the grocery bags. So how far did she lift the grocery bags? This is asking about displacement. So displacement equals what? Okay, so our equation is displacement is equal to work divided by force. So our work was 50 joules. She exerted 25 newtons of force. So that gives a displacement of 2 meters. If we look at the units again, so we have joules, which is kilograms meters squared per second squared, over newtons, which is kilograms meters per second squared. So everything divides out except for 1 unit of meters. So we're on the right track. All right, example number 4. This is our last example. The baseball player does 1,234 joules of work when hitting a baseball into the left field. Assuming the baseball landed 100 meters away from home plate, how much force did the player use to hit the ball? All right, so this is a force problem, so we're going to use the equation solved for force. So we have force is equal to work divided by displacement. So our work is 1,234 joules of work divided by 100 meters. That gives us 12.34 newtons of force. So last time to look at our units here. So we have joules is equal to kilograms meters squared per second squared. We divide that by meters, and 1 unit of meters divides out from top and bottom, and we end up with kilograms meters per second squared, which is equal to newtons. Okay, everybody, keep asking questions. It's how you learn new things.